previous proofs, we could have still used the main strategy and done something and then got stuck after doing that. I like this proof because if you use the main strategies, part one of the main strategy, change everything to sine and cosine. Oh, it's already done. Okay, well, part two of the main strategy, get a single fraction on both sides. Oh, it's already done. Okay, are they the same?
No.
No. That's a problem. Can I change 1 minus cos to something? No, because it's not squared. We can only change things if they're squared. So now we're going to get into what do you do when you get stuck? These are the stuck strategies. I've already mentioned one of them. I'm going to mention it again, but it doesn't work in this case. Factor. If you get stuck, see if you can factor. Usually it gets you unstuck. There's nothing to factor in this one. So then we have to use the strategy of, and I gave it a name. The name I gave it is build the other side. And you build the other side by multiplying by 1. Which at first seems confusing. So I like, now the key thing, I hope you're really good at your 1 times table. Right? Multiplying by 1, 352 times 1. Oh, you guys do know it. Yes, 352. When you multiply by 1, it doesn't change what it equals to. Now, multiplying by 1 can look differently. What's 781 multiplied by 5/5?
781.
Still 781. 5/5 is just another way of saying 1. Okay? So the build the other side strategy works like this. You're stuck. Your main strategy doesn't work. You've got a single fraction on both sides. They're not equal. And you're like, well, maybe I choose something. I choose either the denominators or the numerators. It really doesn't matter. Most people choose denominators because they're more used to that. I'm going to make my denominators the same. This denominator is a 1 plus cos theta. This denominator is a sine theta. So I take this side and I multiply by sine theta over sine theta. And this side, I multiply by 1 plus cos theta over 1 plus cos theta. And that will make sure that I have, and I'm not even going to multiply it out, I'm going to leave it factored. I'm going to have the same denominators on both sides. I'm building the sides so they look the same. And hopefully something works out for me on the top. Okay, but now my denominators are the same. On the right-hand side, if I have sine theta times sine theta, I'm going to get sine squared theta. And on the left-hand side, if I look at multiplying the top, do you recognize the difference of squares? 1 plus cos theta, 1 minus cos theta. That's a difference of squares factored. So you're going to get 1 minus cos squared theta if you multiply that out. Okay. Now my denominators are the same. I still have a problem that my numerators aren't the same. But at least now there's a squared. So could I use one of my Pythagorean identities? Yeah. 1 minus cos squared theta is sine squared theta. Oh, this is exciting. I think this is worth pulling out a fancy pen, or maybe a paintbrush. Oh wow! I feel like I'm gonna get paint on my new pen. Yes.
Would that be more than one mental math thing though?
To go from here to here?
No, because you factor the difference of squares in your head, and then you're
I
changing
multiplied this out in my head and got this. That's considered one step.
it. You don't need to like list it on another row or list
No.
it if there's 5.
No.
Okay.
And then from here to here is also one mental math.
Yeah.
So factoring the difference of squares is something from grade 10 and grade 11. So doing that in one step in your head is allowed.
Okay.
And same thing, if you can factor in one step, you can multiply it back together in one step.
Okay.
Okay? Good question. I like the paintbrush. Maybe I'll have to do a whole question with paintbrushes. Okay. This is the build the other side strategy. So on page, let's see, I've got it right here. On page 620, you have a blank page. I have a list of main strategies we can now use for proofs. And on that paper where I said you could only go up to number 24, you now can go all the way up to 46. And they get harder, and they get challenging. I'm going to do some numbers here. First, I'm going to put ones beside these two, because that was our basic strategy. That's where we started with. Basic strategy, change trig functions to sine and cosine, and then get a single fraction on both sides. I might even write under beside this, because this is a language I used a lot. And if you come to me and you say you're stuck and you haven't done strategy 1, I won't even talk to you. No, I'll probably still talk to you. But I'll say, can you show me strategy number 1 at least? And it might be a bad strategy, but you have to become an expert at strategy number 1. Even questions where it's a bad strategy, you can usually get at least 2 out of 3 marks if that's the only strategy you know. You can pass proofs with strategy 1 only. Well, and know how to do strategy 1. So, okay? Strategy number 2 is this idea of your Pythagorean identities, and I'll put in there, because we saw it here, when you look at the other side and went, oh, we can change everything to cotangent. Being aware what's on the other side, before just jumping in and doing strategy number 1, can often lead to a shorter proof. And then when you get stuck, strategy number 3 here is stuff to do when you're stuck. Check to see if you can factor. Factoring usually makes your life easier. If you can't, maybe you want to build the other side. Make the denominators the same. Building the other side is often coincides with something called multiplying by the conjugate. But if I did a quick quiz right now in class where I said, describe to me what a conjugate is in math, it might not go very well. It's probably not a word you use every day, right? It's not like you're at the grocery store and you're like, oh, let me just figure out that and I'm going to pull up my conjugates. No, you don't use that word very often. So the reason I renamed it as build the other side is because the word conjugate is not a word you use very often. And the word conjugate deals with difference of squares. For example, a plus b and a minus b are conjugates. Whenever you have the same thing with the different sign in the middle, 1 plus, 1 minus, those are conjugates. So the question that we just solved, I'm going to point out what, here we go. The question that we just did had a conjugate in it. Right there, I multiplied this 1 minus cos theta by 1 plus cos theta. I multiplied by its conjugate. But I find that the build the other side is easier to remember and also easier to visualize. So just getting a common denominator here makes this a lot easier. Okay, I'll scroll back because you probably weren't done, right? So now do up to 46 on your proofs page. Right. Yes, if you're only on 14, make sure you get working on it. Come to your next class ready with questions up to 46. Okay? Normally I would say that should take you more than 1 day, but when is your next class?
4 days. Tuesday.
Tuesday? Oh, I've got extras if you don't have that sheet.
Mr. Chair,
Mm-hmm.
I understood literally none of that. Like, maybe the stuff about cos squared theta plus, like, sine squared theta equals 1, but, like, everything else was just, I tried, but I don't know.
That's the proofs, that page there. Were you here when we started our proofs?
No.
Oh, that's probably what is causing some problems.